Hey everyone, happy you're here, happy you're watching, and I'm happy you're listening. Happy my microphone's working. Okay, we just did the parent function of cosine. We did a little deep dive into the unit circle quite a bit. We tried to talk about a few tricks to help us remember what positive cosine looks like, what negative cosine looks like as a shape. And now we're going to apply transformations. We use the letters A, B, H, and K to describe these transformations when they're in this nice form, comparable to vertex form of a parabola, something like that. We've been using A, B, H, and K. If you were my student last year in Algebra 2, we've been using that same setup since then. And we can apply it to any number of situations. So the example we are going to graph right now, let me just check my notes here, so we're going to do this one together. It wouldn't be a bad idea to, once you have it written down, try to do it. Try it by yourself. No one's going to judge you if you get it wrong, right? You're at home right now, or wherever you are, and try. And if you get it right or wrong, either way, press play after and follow along with me, and then we'll take it from there, you know? But if you can get it right on your own, that's a pretty good accomplishment. I would say that's pretty awesome. So if you can apply the new shape, cosine, and all of the rules for sine to figure out this example all on your own, that is tremendous. That's great, okay? The equation we're using is y equals -2 cosine 3 x plus 13 pi over 20 close plus 4. There we go. That is our example. All right. Now maybe you want to write down next to it y equals a. Then next comes your 3-letter trig abbreviation. So trig, but trig is 4 letters, but sine, cosine, tan, you know. Sometimes they don't put a parenthesis in front of the B, so that's okay. I'm just being a little extra right now so we could really see everything separated. And sometimes, like I mentioned in the sine video, they distribute that B and you would have to factor it out, but the B is always whatever's in front of X or theta. And then if you want to figure out the H without having to factor out an awkward number, you take the whole thing and set it equal to 0 and solve for X, and that will give you H if it's not factored nicely like this. But we'll see an example like that eventually, okay? X minus H, close, plus K. Now, as we graph this, we're going to indicate a bunch of things. I'm going to bust out my highlighters so we can label it with the highlighter, and we will be talking about indicate. We want, this young gentleman, we want to see the sinusoidal axis. And if you have highlighters or crayons or something, this should be 2 words. I wrote that awfully close together. H, or your first tick mark. If you want to put even a dashed line there, so if you did that Desmos activity with me, you saw the dashed line moving left and right, moving up and down. So that dashed line, what that does, it comes in handy because it's like a crosshair showing where the origin is, but cosine starts either above it or below it, depending if it was positive or negative. So we just want to kind of mark up that whole area and say, like, this is where H is. It's not here at this dot, it's above it or below it, but this is H. This is where my graph has shifted, either left or right, okay? Do you want to go down, little guy? You're just going to want to come back up in a second. Okay. All right. We also want to mark up the amplitude. We want to sort of just show in here the quarter period. let's hyphenate that, you know, so it's like one word, and then just the period in general. And I think that's it. Okay, so we're gonna do all that. I'll color code it as we go. But when we see that it is cosine, you always have to kind of slow down. I would say one of the main mistakes people make, while I color code this, one of the main mistakes people make is like they do all of the stretches, compressions, reflections, all this stuff beautifully. Horizontal shift or translation, vertical shift or translation, excellent. But they didn't draw the right function. They drew sine, even though it was cosine, you know, something like that. So just be careful. Make sure you take care of addressing exactly what it is. So first and foremost, even though I'm still color coordinating, you look up at your equation and you say to yourself, all right, this is going to be a cosine graph. How do I know that? I mean, it says cosine, okay? It's going to be a cosine graph. It could take on, one cycle could take on one of two shapes. It could take on the shape or the cycle, the visible cycle of a positive cosine or of a negative cosine. What does each of these two things look like? Do you remember what positive cosine looks like in the parent function? Do you remember what negative cosine looks like from the parent function? If you do, commit to it and put it on your paper somewhere, like I'm about to do right now. So right now, positive cosine, just putting a little note for myself. I don't know why I put theta this time, whatever. If it's positive cosine, we're gonna have a shape like this, like a V opening upwards. In the middle, concave up, looks like a pup. Concave down, looks like doggy ears. There's positive cosine. And then the negative cosine, which is what we are dealing with today. Negative cosine, I guess I put theta, so I'll put theta again. Will cause a vertical reflection. And then we'll have 1, 2, 3, 4, 5. Concave down, looks like a frown. Kind of looks like a ghost or Darth Vader's head or something like that. And that is the negative cosine shape. Since we have a negative in front, that caused that vertical reflection, among other things, of all these other numbers. So I'm going to start by making the 5 dots and drawing a little bit bigger of this without any axes right over here, more or less in the middle of the paper in my space. I'll go back and do my graphing hack where I draw my axes in after the fact so that everything fits nicely and it looks very well thought out. 1, 2, 3. The closer you smush these together, the harder it's going to be to label stuff. So really, if you really want to make your life pretty easy, I would really stretch them out pretty far apart. It gives you a lot more room to label, okay? It's a little crooked, so we just make our dots bigger, you know? There we go. And I'm gonna draw my shape right there. Don't make it pointy. This point right here and right here, while in the parent function, it's a 0. On any other graph that has been at least shifted vertically or, you know, up or down, it will be not a 0 specifically because it won't necessarily cross the x-axis there since that's the name for x-intercepts, but it will be at the very least a point of inflection where the concavity switches from one to another. Point of inflection. All right? Now, what have I dealt with so far? So far, I have addressed the negative and I have addressed the cosine. Okay, that's where I'm starting. The negative and the cosine gave me this shape and those points. All right, all from the fact that it's negative cosine. Next up, I'm going to deal with my +4. The +4 is my plus k. It's your vertical shift. If you still don't know this, you need to come for extra help. That's the solution, okay? +4 moves your graph up vertically 4 units in the positive direction. That will pass through the points of inflection right over here. So this will be 4. It's my sinusoidal axis. It's up 4. Now, it's not my x-axis, just my sinusoidal. It's a horizontal line. The equation of all horizontal lines is always y equals a number. What number does y equal here? Well, it equals 4, silly. Okay, I'm just drawing it little for myself or writing it little for myself. Once I know where my x-axis is, then I could really label that 4 on the, my y-axis. Both, really. I could really label those numbers more solid. Okay, plus 4 is done. Next thing I'm going to deal with is, really start on the outside and you're going to work your way in, is the 2. The 2 took my regular cosine wave, which went up 1 and down 1 off the sinusoidal, and stretched it out. Stretched it out further, like this. So now that means that this is 2 units up. That means that this, and every other one that will occur, those are 2 units down. So we can maybe go ahead and put, say, a 2 over here, because an amplitude's always really a positive number. A for amplitude, A for absolute value. A is the letter I use for that spot. Absolute value of -2 if you want to put 2. You don't really have to label it all the time. We're just doing it in this example. And right there, we've marked up our amplitude, but we should also include y values that go with it. If this is 4, and, oh boy, and this is going to be 2 units above it, then this x value is 6. What would the bottom x value be then? The minimum, the maximum, midline. Don't say -6. Don't be that person. It is 2. 2 units below 4 is 2. 2 units above 4 is 6. So from there, let's now go to eeny, meeny, miny, mo. Which one's easier? That one, I promise, okay? X plus 13 pi over 20. You are not being a scientist to figure out, some crazy experiment, mixing chemicals and figuring out what happens in order to figure out these tick marks on the x-axis. I know it's a daunting task and a little scary, and it looks really impressive, but it's really not that hard. This is to the right, this is to the left, 13 pi over 20 units. It's in the bunker house, BH. Do you want to go to the bunker house? I don't want to go to the bunker house. Which way am I shaking my head? Left to right, bunker house. Everything's backwards at the bunker house, okay? So plus, move it left. 3, big number, compresses it. All cool, cool with a K. All cool, outside with A and K. All cool, nodding up and down. All right, nodding up and down. This is up and down. It's all cool. Everything's normal. 2, stretches it twice as big. Plus 4, up 4. No funny business, okay? So 13 pi over 20 is going to be where this tick mark is above. Oh, and if this is 6, 4, and 2, where's my x-axis? I have enough information. My x-axis is somewhere below. So you don't have to be to scale. We could always kind of put a little zigzag guy in there and kind of pretend like this is a little morphed and stretched out, but it's because we broke our axis. Don't worry. So this right here, we said it was left, bunker house. So that's, now I'm gonna actually put an equal sign right there, and I don't know if you can hear that. What do you want? He could do math. I'll show you at the end of the video. He knows the difference between the sine wave and the cosine wave. So if you watch all the way until the end, I'll show you how my dog can pick out the difference between sine and cosine. I promise. He knows math. I'm going to put an equal sign here, and I'm going to actually write negative 13 pi over 20 here, because chances are you're going to need a common denominator. I'm going to have to pause in a second to get him a treat. A common denominator, to add that quarter period every time, it's not always going to work out nicely. So when I write that negative 13 pi over 20, which I got from right here, I'm going to write it a little extra to the left and leave a nice spot under that tick mark so that when I more than likely find a common denominator, I'll write it right over there. And then the rest of my tick marks will have that same denominator. So I'm also just going to go right here and put a tick mark under each of these dots because these are going to be really critical numbers on my x-axis. I should put an x right there. Also, if this were positive, then that would mean if I move to the right, they're all positive. So I could just draw my y-axis here. However, it's negative. I don't know when it's going to change from negative to positive. If they're all negative, I'll draw my y-axis somewhere on the right. If it transitions from negative to positive somewhere here, I will just stick my y-axis somewhere between the negatives and positives, okay? So let's just mark that with the color we need, and that was pink, our first tick mark. And we have negative 13 pi over 20 and leaving some space for its alter ego with the common denominator over there. If you wanted to kind of go up and draw a dashed line, kind of I imagine like, those light beams that when there's a grand opening somewhere, and they're like all up in the sky, like the bat signal, kind of like that, but it's straight up and it's like, this is H. Okay, this is where we start. That's what it is. Oh, and then right here. Okay, so even though it says plus in the equation, bunker house, it's the other way. It's crazy. All right, the only thing we haven't dealt with yet is the B value. The B value in this problem is 3. Bunker house. It's a big number. Is it going to make it bigger? Nope. Smaller. It's going to take this and compress it to 1/3 of its size. But here's the deal. When you have something that goes on indefinitely in both directions, you have to compress it from 2 sides. And what is your middle point that you're compressing it towards? Well, the middle point we're compressing it towards is this pink line where H is. So we're squishing it there. So guess who doesn't change? The pink one where the H signal goes up. Okay? Doesn't move. Everything here is going to get closer. Everything here is going to get closer. But by using this strategy, too many people are like, how do I figure out those other points? By using this strategy, it just works out. Relax. Okay? Relax. So 3 is the B value. It's not the period. Okay? B equals 3. Period. Period equals, for cosine and for sine, 2 pi over B. So 2 pi over 3. What else could I really include? The period is from there to there. How long is that? That distance from start to finish. What if you only had a graph? How would you figure out the period? If these are labeled, subtract your last spot minus your first spot. How far apart are they? There you go. You're welcome. That's the period. Okay? So we're going to leave that there. I'm leaving a little space because I'm probably going to need to find a common denominator. Next in line is finding a quarter period. LMNOPQ would be the next letter in the alphabet anyway, right? The quarter period is 1/4 of the period. Literally, change that into an equation. Little squish, sorry. Reduce this. 2 and 4 become 1 and 2. Final quarter period is pi over, ooh, that's really squished, this marker's too thick. Pi over 6. Okay, this is pi over 6. And now what about the quarter period? That's the whole period. What am I gonna do? Take my first point, add the period, get my last point, then what? Find the midpoint. Midpoint with fractions. It's like super fractions. Then find that midpoint and that. No. We are not crazy. What are we gonna do instead? less crazy. We are going to just add the period's quarter amount, a quarter period. First, we add it once to wherever we start. We'll get that tick mark. Then, by that point, we should already have a common denominator. Then we're going to add again, quarter period again, whatever the quarter is, Q. Get that tick mark again. And one last time. So we add the quarter period 4 times. That makes it a whole period. We go from beginning to end. We have all 5 tick marks labeled. We're done and we're geniuses. It's amazing. So the common denominator situation, let's analyze. We are starting at negative 13 pi over 20. We are going to add a quarter period 1, 2, 3, 4 times. The quarter period and H, so HQ, headquarters or whatever, okay? H and Q need to have a common denominator, H and Q. So I didn't need it for the period. I don't know why I was thinking that for a second there. So pink and green in this case. So let's do a little brainstorm in this little cloud. H was negative 13 pi over 20. Q is pi over 6. What would the least common denominator be? It's not 6. Please don't say 6 or 2. The greatest common factor would be 2. But the least common denominator, so the greatest common factor is little, and then the least common denominator is bigger. It's going to be 60, okay? That's the first number that when we count by 6s, count by 20s, that they both achieve, or that they both hit. They're both multiples. If you need that explanation, the fun way again, which is kind of helpful, in the SINE example video, I would go back there, all right? And I break down the common denominator situation. So what am I going to multiply this on top and bottom by? 3. I promise if you do that trick of the prime factorization, 3 will be what it's missing and crying over. This will be missing a 2 and a 10. I'm not a 2 and a 10, a 2 and a 5, which is 10. So I'm going to multiply by 10 on top and bottom. So what do both of these turn into? This is going to be negative 39 pi. I'm squeezing it, so I'm speaking slowly, so make sure you're writing it. Negative 39 pi over 60. And this one is positive, because quarter period is going to be positive. 10, now I wrote Q. Pi, 10 pi over 60. Negative 13 pi over 20. Under here, I'm going to write negative 39 pi over 60. That's still that first tick mark. If I add a quarter period, 10 pi over 60, what will this tick mark be? You could do this without a calculator. Come on. Negative 29 pi over 60. Add another 10. Gotta keep adding that quarter. Add another 10. Negative 19 pi over 60. Add another 10. Negative 9 pi over 60. Don't you see how easy adding fractions is? Remember when you were scared of that? Yeah. It's not hard. Add another 10. Don't mess up here though. Positives and negatives. I know that we're in pre-calc, but we still mess up sometimes. It's not 9 pi over 60. You're adding 10 to negative 9. Careful. That's going to be 1 pi over 60. Now, all I have left to do, I drew my x-axis, is really just add my y-axis, label 3 spots, and I'm done for now. We'll talk about domain and range in a separate video. It's a really important topic, but for right now, we just need to take care of that y-axis. Now, look at your 5 tick marks. Negative, 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 positive. Since the y-axis is the gatekeeper of the positives and the negatives, it is on the border, then which one's a little closer to the y-axis? It's going to be right around here. I know this is not the scale. Again, it's fine. Carefully draw it. You shouldn't pass through this tick mark. This dot, this point, that minimum should be to the right of the y-axis, okay? So just be careful. Use a ruler if you need to, but just go slow. midline or sinusoidal, that tick mark means this is 4, right over there. Then here, I'm at 6. And down here, I know this dot is like massive, but the minimum right over there-ish is at 2. And anytime, you don't really need it in this case, but anytime we need a little break, you just put a little squiggle and it fakes it for you. And maybe you want to show 2 is just measuring from there to there. I don't know, whatever you need to do to measure that so it's not quite in the way. And that's really all we need to call that y. And it's probably the most beautiful graph you've ever made. Don't you think? I think it's so nice. All right, so that's the end of this example. Let's write down what I want you to do on your own. So on your own, for homework, for your assignment, you're going to graph the following trig function. Just running out of paper in that notebook. Ready? On your own. Graph y equals 3 cosine 2 times the quantity of x minus 5 pi over 7 plus 6.5. Only really graph what matters. Don't graph 100 tick marks in every which way. You should have about 3 tick marks on your y-axis. You should have 5 on the x-axis. You should see your x and y-axis when you're done. You should have the shape of your graph there, and we're good to go. You could also start exploring the idea of domain and range. Remember, domain goes from left to right, and range goes from the bottom to the top when you describe it, and we should be using interval notation, okay? Okay, so I told you guys my dog could do math. So if you want to see, I drew 2 graphs on these little cards over here. This is clearly cosine, and I also drew sine on this one. So if you want to see my dog identifies sine and cosine, then you're going to have to click through to the next video. And he's very excited. He wants to do it for you. And if you want to see this little guy, Dallas, sit. If you want to see that good boy, pick out a graph, and you're going to have to watch the next video. All right? So I hope you click through.